Video, I'm going to talk about Python notebooks. Many people use them and they have some really good properties. But I don't like them for serious coding. I cannot and would not ban them from my class, but because I'm an old cranky man, I want to say a couple of words about the bad habits that they sometimes seem to engender. If you love notebooks, and whether it's a Jupyter notebook or a Collab notebook, and they work for you, great. Feel free to ignore this. But if you're just jumping into Python, you're not so experienced, and you want my opinion on how to code, stay tuned. My suggestion would be to get a good editor, Microsoft Visual Studio, Emacs with Python mode, and syntax checker. Put code into classes and functions that encapsulate small atomic actions and all relevant data. Then write unit tests to ensure accuracy. Have a framework to periodically test to make sure things are working as intended. This could be something like integration testing or a makefile. Sadly, I don't get to code as much as I would like these days anymore, but that's my preferred way for doing it when I do get the chance. But if you go out on the web, a lot of the tutorials you'll see tell you to do something completely different. Just fire up a notebook and just start coding. Here are 7 reasons why I think that might not always be the best idea. 1. It leads to spaghetti code. If you haven't heard of spaghetti code before, it's code that goes all over the place and you can't read it linearly to figure out what's going on. This happens because notebooks have a great property. One of the great things about notebooks is that you can start coding immediately and see what happens. So the order of the code in a notebook reflects what you did, not the minimal steps that take you to an answer. I do this too, but I do it on the command line. And then, because it's an ephemeral command line terminal session, everything is lost. And so as I go, I copy paste into a well-organized, structured file for my quote-unquote real results. But because the notebook never forces you to leave, it just stays there. And the code often just meanders all over the place in this spaghetti-like structure. If you need to find a variable or a function and you're using it on line 24601, you might need to scroll past lots of other code to find it. And sure, you could Control F to search for it, but that makes life harder for someone else who wants to use the code later. But because the notebook never forces you to leave, never forces you to go home, it serves as an immortal testament to your entire thought process. It just stays there. And that often ends up in code that meanders all over the place, organized as you wrote it. That's great for a sociological exploration of what it takes to code something. But if you need a variable that you're using on line 24601, you might need to scroll past lots of other stuff to find out what that actually is, how it was instantiated, and how you got there. And sure, maybe you could do Control F to search for it, but that makes life harder for someone else who wants to read the code later. And that poor somebody could be you after you've forgotten how you wrote the code in the first place. Reason number 2, limited reproducibility. A side effect of writing spaghetti code executed in a notebook environment is that the state of the code is often indeterminate. You'll run block A, but not block B, then block C, then you rerun block B just to make sure that it ran. Then maybe you run block A, maybe you forgot if you ran it before, then C again. I went through this kind of fast. Can you tell me what the answer would be here? And it could be very different than if you went through this linearly like a quote-unquote normal program. Of course, you could clean things up, but who has time for that? You have an answer. Who cares? Reason number 3, dead ends and Cruft. Less serious, but related to the previous issue, is that because a notebook is often used for exploration, much of the code that you write ends up being useless for the answer. And there isn't an incentive to clean it up. It just sits there like junk in your attic. It's not getting in the way, but it's not really doing anything useful either. But then when you need to find the thing that you really need, or when something breaks, it becomes much harder to find the answer. Much like Overleaf and Google Docs have discouraged the use of version control for written documents, that's another rant, Notebooks have done this for code. A notebook is online so you can share it with others, so it does everything that Git does, right? No, even if you're working by yourself in a cabin in the woods, you should be using version control. Version control lets you track atomic logical changes. You make a change, you save it, you commit it, realize you screwed something up, and then you can roll back the commit. The great thing about Git is that this can happen even after you've made plenty of other commits. What I often see in notebooks is duplicated code as things get tried out, worksheets named after dates and things like that. Lots of dirty copy pasting and not using the logical structure of, say, a Git branch to try out something new. Reason number 5, code encapsulation. As a project gets more and more complicated, it's useful to put the functions and data in one place. Like, for instance, a class. Once they're in there, they're called members and methods. This can help you prevent copy-pasting code, which leads to more mistakes, another bad side effect of notebooks that I've seen, and help you run more efficient experiments, since you might need to instantiate 5 different copies of a model. Proper encapsulation helps you do this. Number 6, a lack of documentation. This is a perennial problem, and you can't just blame notebooks for this. I'm guilty of this too, even when I'm writing in my favorite IDE. But I think notebooks make this a little bit worse. Because notebooks are for quick and dirty exploration, why should you waste complicated doc strings for your functions and classes? Real editors can do things like highlight when a function is missing, and give type hints or doc hints. And you get rewarded for creating good doc strings and type hints in the ecosystem of a real IDE. Lack of unit tests. And again, this can happen without notebooks. But notebooks make it harder. With a notebook, you test and poke and prod until it works. With test-oriented development, which is better in my opinion, you write an API first, write the tests, see them fail, and then you see them pass. And while using a notebook initially will also give you code that mostly works, the beauty of unit tests is that you can keep them around to monitor your code to ensure that the code remains correct. Okay, that's Grandpa Graber's take on why you should write your code the old-fashioned way while listening to vinyl. But the real reason I go on this rant is that often students need to make the transition to real software development outside of a notebook, and the transition hurts. And sometimes it just never happens. You stay in a notebook because the transition costs are too hard. You grin and bear it, and you just keep going. That's not to say that you can't write good code in a notebook. I've seen people do it at big companies. It just takes a little more effort, and hopefully, even if you keep writing code in notebooks, you'll keep this in mind as you try to prove me wrong. This is just one video from a course that I'm teaching. If you want to get the whole context, check out the course webpage, linked below. There you can find all of the videos in the right order. YouTube likes to show you older videos out of order, homeworks, exercises, and recommended readings. And if you want to help other people find videos like this, please be sure to like and subscribe to provide a big gradient to the algorithm.